Okay, algebra folks, this is Unit 7, Notes 3. We're talking a little bit about combinations. Combinations are different than permutations. Permutations was last section. Combinations is this section. The number one difference is whether or not order matters, okay? The last one, permutation, order mattered because you were talking about an arrangement. Here, combination, we often use the term grouping, okay? So, let's take a look at the problem here. Basketball league has 5 teams. 2 of the teams are chosen to play one another. How many different possible matchups are there? Make a list. So you've got A, B, C, D, E. You have got 2 of the teams to choose. So A can play B, A can play C, A can play D, A can play E. B, I can't put BA because in this case, A playing B is the same thing as B playing A. So that would be counting it twice. I'm not going to do that. Not in this case. Okay, but I will have B playing C, B playing D, and B playing E. And once again, I'm not going to put C playing B because these two would be the same. Okay, B playing C, C playing B, that would be the exact same. And don't give me any, lip about, well, what if one's at home and the other one's at home? No, the same 2 teams are still playing. All right, so then it's going to be C, D, and C, E. And then it's going to be just D, E. So my total number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's going to be a total of 10 different possibilities. So combinations. Combinations are where we talk about listing of objects in which order is not important. Please take note of the formula. Formula is a little bit different than the permutation. All I did was add one more factorial when I take an object. Okay, this one is also said n choose r. So I can say n choose r. Both n choose r and n choose r refer to permutations or combinations. You've just got to be able to distinguish between the two. So if I said 6 choose 2, that means I'm going to take 6 factorial over 6 minus 2 factorial times another 2 factorial. So that's 6, 5, 4, 3, 2, 1. On the bottom, I'm going to have 4, 3, 2, 1 times 2 times 1. A lot of times, if you're going to compare a combination to a permutation, the combination is going to be smaller because when I look at a grouping versus an arrangement, a grouping is, there's going to be far fewer groupings. Okay, remember, order doesn't matter. So that means A, B, and BA are the same. So I don't count it as many times. So when I cancel these out, if I just did that, then it would be like a permutation. But I've got this last factorial here. So this ends up being 30 divided by 2. So there's 15 ways to do this. Likewise, if I take 8, choose 3. So that's 8 factorial over 8 minus 3 factorial, 3 factorial. So that's going to be 5, 4, 3, 2, 1 times 3 times 2 times 1. So I add on this other little factorial here because it's a combination. Cancel, 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 cancel. Now I'm left with 3, 2, 1. So here I got to remember some of my rules. So 3 times 2 is really 6. So I can cancel out that 6 and cancel out that 6. So I'm left with 8 times 7 divided by 1. So that's going to be 56. So a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Picard, next door to me, needs to choose 12 students out of the group. How many ways can the 12 students be chosen? So, doesn't matter if you get chosen first or last. No, you're still a peer tutor. So that's kind of what I'm looking for. So 7 seniors, 5 juniors, 4 sophomores. So that's 7 and 5 is 12 plus another 4 is 16. So I'm picking 12 of them to be tutors. It's going to be 12, 16, choose 12. So mathematically, that's what that's going to look like. Forgive my ugly 13. And have to draw into Mr. Picard's face. Oh, almost. So then I'm going to have 4, 3, 2, 1 times 12, 11, 10, 9, 8, 7, 6, 4, 3, 2, 1. So cancel, 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 cancel. This is nice when it does that. So now I can still do a little bit of simplifying over here. All right, there's a couple different ways you can do it. Here's what's kind of looks easy to me. 16 over 4 simplifies to 4 over 1. 15 over 3 simplifies to 5 over 1. 14 over 2 simplifies to 7 over 1. So on the bottom, all I got left is 1s. On the top, now I've got 4 times 5 times 7 times 13. So 4 times 5 times 7 times 13 is going to be 1,820. So that's my answer. You and 6 friends are going to eat lunch. You can only take 2 people with you in your car. How many different combinations of friends can ride with you? So you're obviously going to go in your car, but you got to pick which of your other 2 friends are riding with you. So that's going to be 6, choose 2. All right, doesn't matter if you get picked first or second, you're still riding in the car. We're not being picky about who's sitting where. So it's going to be 6 factorial over 6 minus 2 factorial, 2 factorial. So 6, 5, 4, 3, 2, 1, 4, 3, 2, 1, 2, 1. So 4, 3, 2, 1. This 2 and this 6 can become 3 over 1. So that's just going to be 15 different ways. So a gym coach selects a track team of 4 athletes from 14 to represent the school at a track and field meet. Find out the number of teams the coach can make. So I'm going to take 14, choose 4. All right, so that's 14 factorial over 14 minus 4 factorial, 4 factorial. So 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 10, 9, 8, 7. Sounds like I'm launching a space shuttle. 3, 2, 1 times 4, 3, 2, 1. Liftoff. All right. So 10, 10, 9, 9, 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. So now I've got 4, 3, 2, 1 over here. And then I've got 14, 13, 12, 11 up top. So hey, take a look. 4 times 3 is really 12. So that those 2 cancel out, and that 12 cancels out. I've got 2 over here, and I got 14 up here. That can become 7, and that goes away. So I got 7 times 13 times 11. So 13 times 11 times 7 is going to be 1,001 ways. All right, so now you got to figure out, is it a permutation or is it a combination? Which one do I got to do? And then solve it the right way. So a subway car has 8 empty seats, a one stop, 5 people enter the car, and no one gets off. How many ways can the 5 people arrange themselves in the 8 empty seats? Here's the dead giveaway, and here's what I'm looking at. It says arrange. Okay? It says arrange. That's my dead giveaway. It's a permutation. Here's the other thing that kind of tips me off. Once you sit in a seat, can anyone else sit in that seat? And don't give me any lip about, yes, you can sit on your lap. No, once somebody sat in that seat, nobody else gets to sit in that seat. That tells me that order matters. All right, if you get on there first, that means you get to choose your one of 5 seats. Or you get to choose your seat, then nobody else gets to sit there. All right, so it's like out of 8 seats, P5. So it's 8, 7, 6, 5, 4, 3, 2, 1. Over 3, 2, 1. So boom, boom, boom. So 3 of the seats are going to be empty. So there's 6,720 ways 5 people can fit into 8 seats. A history test lists the names of 5 presidents, and each student is Choose 2 of them to compare them in an essay. How many different pairings are there? Pairings is my dead giveaway here. Pairings is my dead giveaway. So like if I take, Lincoln and then Jefferson, is that going to be different than Jefferson and Lincoln? Well, no, because you're still comparing those same 2 guys. So order doesn't matter here. So it's not a permutation, it's a combination. So it's going to be 5 choose 2, 5 factorial over 5 minus 2 factorial, 2 factorial. So 5, 4, 3, 2, 1 over 3, 2, 1, 2, 1. Cancel, cancel, cancel. 20 divided by 2 is going to be 10. So a survey asked people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy watching each sport. How many possible responses are there? So when you say rank, that means you're going to go like first, second, third, fourth, and fifth. So to me, that's a permutation because you got to look at, it's a little bit different here. It's kind of like saying 5 choose 5, or 5p5 rather, 5 choose 5 with a permutation. It's kind of thinking about it a different way. I've got 5 sports to choose as my first one, 4 to choose as the second one, 3 to choose as the third one, 2 to choose the fourth one, and there's only going to be 1 left for the last one. So that means there's going to be 100 different ways somebody could respond to that question. So 20 students in the speech club. 3 of these students are chosen to represent the school at a regional competition. How many different groups of 3 students can be chosen? Groups is my dead giveaway. All right, grouping means combination. Here's kind of the other thing you want to think about. Doesn't matter if you get picked first or third. Are you still going to the regional competition? Yes. Order doesn't matter. So that's going to be 20 choose 3. So it's going to be 20 factorial over 20 minus 3 factorial, 3 factorial. So you go 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, dot, 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 dot. There's a lot of dots. This is a big one. I really hope it's towards the end. On the bottom, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then I'm going to put 3, 2, and 1 out here. Because here's what I get to do. Now I'm just left with 20, 19, 18 over 3, 2, 1. So what I'm seeing is 3, that becomes 6, 20 over 2 becomes 10. So I'm left with 10 times 19 times 6, which is 1,140 ways. All right, how many ways can the letters in the word combination be arranged? So remember that this was the one where you take the total number of letters, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, over anything that doubles up. So like there's 2 O's, there's 2 N's, there's 2 I's, and I believe that's it. So when I do that, I end up with 4,989,600. So 4,989,600. All right, don't take the quiz on Schoology because it doesn't exist. So, but do your notes, finish those up, look them over, get the assignment, and do those too.